and share this. We can see the ILM now. Objective 3, so safety procedures required when handling tires and wheels. What we're going to talk about here is not necessarily all of the safety aspects required with changing them. Like I said, that you need some specialty training, especially when it comes to swapping split rims with the tires on split rims. What we're going to talk about is when it comes to while you're doing things that are absolutely something you're going to end up doing, like brakes, wheel seals, CVIP inspections, what you're going to need, essentially demounting rims and mounting rims. All the safety aspects involved with that and things just to be cautious of. So you always have to be careful, and this doesn't just necessarily mean for a split rim either. Even tubeless disc wheels, one-piece rims can blow apart in this manner. And so you always want to think of where the most of the force will go. Usually it's going to come out the direction of the rim or the sidewall like this. This picture is specifically talking about the locking ring on a split rim coming off. So these tires, how much do you figure something like that would cost you, Ryan?
How much they cost?
Yeah.
Tens of thousands.
Tens of thousands, yeah.
Yep.
I can't see your screen. It's just buffering for me.
Oh, oops, cruddy. We're having bad internet then. That's no fun. I'm on page 25 of the tire ILM. Essentially, it's that picture of the loader holding a very large tire up.
I've actually seen a few of those that drive on the bed of a big truck there. Somebody was delivering them. Must have been to the mine.
Yeah, I'd imagine so. And yet they're very, very, very expensive. So these tires, if you can get in the business of repairing them, I've seen that people do repair those tires, or they would try to, because they are very, very expensive. Are you still buffering, Ryan? Unfortunately, we're having connection issues.
I can see it now.
Okay. So how much do you figure one of those would be worth? Do you have any idea?
I forget. I've Googled it before, but I've only ever met one person that worked up in the mines up north in Fort Mac. His name was Mark Driscoll. And he didn't really talk about how much they cost, just about what changing them was like.
Yeah, and yet again, you can see the piece of equipment involved just with moving the wheel assembly, right? It's a very large piece of equipment, and so it's not something easy to do, a very large job. Okay.
It's the same size as the equipment.
Yeah, exactly. So, and they become very, very expensive as well.
Even a 777 dump truck, something that would be normally the largest thing that anyone's ever seen, that's actually still support equipment up there. It's pretty incredible.
Mm-hmm. Yeah, exactly. Always read these danger and warnings. These are always very important when we're talking about anything in these ILMs. These will be important. So talk about deflating tires and removing pressure from tires before we demount them. And here they give the basics of what somebody like Ryan is probably very familiar with, how to manually remove these, right?
Yeah.
Yeah, exactly. So this is how it works. You have bars and hammers, big bars, and it's a very good workout. Like Ryan said, essentially you're giving yourself a really good workout. If you're working properly and not doing abnormal lifts or incorrect, like you're not jarring your body too hard, you won't get too sore and you'll get in really good shape. So that is the directions on how to remove the rubber from a rim. For me, as far as I'm concerned, that's nice. That's good. It's good that they tell us that. So if you have to do it, that's great. Now, here is how you're going to be removing tire from an off-road piece of equipment. That's nice. They're just showing that they have a special clamping jaw to hold this, I believe, is holding it on here while you're deflating it. And then you can use this bar to pry off the ring. This takes off the lock.
That's pushing the main flange back so that you can access the lock ring.
Lock, gotcha. So this is pushing the flange. It's essentially doing what this first bar is in here, right? Pushing back the flange here so you can see and remove the lock. Instead of pushing on the rim, though, it's pushing right on the locking ring, right?
Well, the flange on that wheel moves separately from the actual wheel, and so you have to push the flange back in order to get the lock ring out, because the flange has a step that goes over the lock ring to protect it from popping. Yeah, right there, from
Right.
popping out. And so on that big tire, it's kind of sprung and it's pushing that flange out. So that machine pushes the flange in so you can get the lock ring out.
Gotcha. So it's pushing this removable flange here. So how these work, it's you're gonna have the tire tube inside. Oh, my pen's off. You're gonna have the tire tube inside of here. Come on, turn on. The tire tube inside of here. This is pushing back on this flange here. This piece will move, and this is essentially the other lip of the rim. What we're used to seeing in a one-piece rim is you'll see that where the bead rides, that lip, it's just all one piece, right? On a split rim, you have inner portion, and then the outer portion is flat like this, and that other piece can move and it's separated from it. So it pushes it back. You can take the lock out then. This ring here is what's locking this in place, stops it from being able to come off the rim then once it's on there. Yet again, that's nice. Most of you won't see this very often in your careers, but if you do, you need to watch out for different types of damages on rims, cracks in the flange here, in the disc flange, very bad. Mounting holes, very bad. A sprung side ring. So it's hard to see necessarily what they mean here, but instead of being a perfectly nice ring, it looks sort of like a coil spring now. So it's coiled up. Instead of these two sides sitting perfectly even with each other like this, if you laid it down on a bench, they're essentially going to be at different heights with each other. So you'd have one sitting really high up and one sitting really low down, like this, rather than like this. Does that make sense? That's what this sprung ring looks like. Essentially like a lock washer. If this is going to end up looking like a lock washer, then it is bad. Broken side ring, also very bad. Wheel nut damage, obviously very bad. We can't use these components, need to be replaced. When you're using a multi-piece rim, you need to make sure that they have the correct matching part numbers on them, or you can't use them. Is that what Cal Tire tells you to do, Ryan?
Yes.
Yeah. So these parts together, this is actually the best picture for that, what Ryan was telling us about. So this is that side ring and how it is movable. It's a separate piece from the main part of the rim base here. This is the kind that has that locking ring in it, okay? So 2-piece and a 3-piece, very similar in that this one side flange moves. So they call it the side ring. It is the flange that moves, and then you have the opposite flange that doesn't move. Yeah, that one.
Okay, those rims are.
So these are actually a tube type split wheel. And you can tell because there's no O-ring. So that continuous side ring on a tubeless split wheel would actually come out underneath where that split lock ring does. It would be like an S shape. It would kind of come out onto the wheel, and there'd be an O-ring under there. The lock ring wouldn't have a piece that comes underneath. It would just kind of be a diamond shape cross section where right about where your mouse is on the left.
Mhm.
Yeah, it would be a diamond shape there instead of that long skinny one. But that long skinny one is designed so that it fits underneath that continuous side ring and cannot blow out because it's trapped under there when there's pressure in the tire.
Gotcha. And yeah, I haven't seen many of these, so knowing the difference between the tube and the tubeless, you're absolutely right. You can imagine you'd have to have, if this didn't have a tube inside of here, because the tube is what holds the air pressure, right? You'd need to have some sort of seal to keep the air pressure inside of there. And so yeah, O-ring would work great for that.
The tube style is pretty much common in overseas, where my dad had trucking stuff, and we were using this style. And I remember it was a 3-piece, where I don't know if Ryan, have you used that style with the 3 pieces, and there is a tube around it?
I've used 2-piece wheels, 3-piece wheels, and 5-piece wheels.
Yeah, these are a 3-piece style, and has to be put together and make it circle.
Yeah, depending on where you are and where you are in the world, you'll see all different kinds of things. So
Yeah, I haven't seen it here at all.
if you're inflating tires, you shouldn't use more than 40 psi to fully seat the bead. I've seen what tire people do to seat them. Should be putting them inside of a safety cage. We saw those videos about safety cages. I'll probably play them again for those of you who didn't see them. And this is the important thing to remember. All of these safety applications and OH&S regulations. We actually have quite a few more regulations in the States, in different states, than we do in Canada when it comes to filling up with tires. For instance, in some states, you can't actually even top up a tire unless you have a certain length lead on with a locking chuck. So often how we air up tires leaning down beside them, you can't do that there. You have to clip the lock. It has to clip onto the valve, and then you have to walk away from the tire and be able to air it up remotely like that. So yeah, read through all those safety regulations. Now, this is the part where we're going to be looking at things all the time. So you can see the tire is see-through now. Good. What are we going to be typically looking for on tires is tread depth, tread quality, right? Wear and life remaining. We're also going to be looking for any kinds of damages, cuts, nicks, and gouges, down to the cords, bulges, anything like that. Other than that, when it comes to, oh, the tire is damaged and need a new one, a large portion of you probably going to be calling somebody like Ryan, or if you're in Ryan's boots, then you're going to be getting new rubbers and changing that over. Balancing them as well, maybe. On a dead axle, so this is, they call this a dead axle, it's non-driving. This is a steer axle. I can tell because of the way the hub looks, and there is only one wheel on it instead of a dual assembly. Now in this one, we have the way the brake drum is attached is very typical of what we'll see with Bud style wheels. So the drum is piloted by the hub, and it is held on with the wheel nuts as well. So in order to change this drum, you do need to take the wheels off, demount the wheels. So a non-driving axle, and here's a driving axle. So we'll talk about bearings on a trailer, non-driving axles. Bearings on a trailer dead axle. The only difference between that and a driving axle is the spindle is hollow. Okay, that's where our drive axle comes through. Remember I said that we had a trailer that was coming through and he kept on losing all of his oil? It was going through the hole in here. They could use the very similar tube that they have here with just a different housing attached to it, and you just plug off the end and it can become a non-driving axle or a dead axle. On our axles, these are the pads that we were talking about that drive the drum and then drive the wheels. These are the ears on a hub piloted wheel. Okay. Axle shafts are retained inside of the hub with bolts, actually they're studs, nuts, and then these dowel wedges. Looks like little cones, and they are right in here. Some of them don't have them. A lot of times that is what we're using to maintain our alignment between the components while it's rotating, okay? They're right in here. We want those there so that we make sure this axle shaft isn't sitting incorrectly like this, too low of an angle. That's obviously very exaggerated how low that is, but we get it off circuit, or it'd be out around. It's a good way to term it. They're jammed in there. Who's seen those jammed in there before when you're trying to get a drive axle shaft out?
I had to beat on him with a hammer.
Yeah. Usually what you're going to end up doing is hitting on the center of the drive axle with a hammer. Would you take these nuts all the way off while you're doing that?
No, because look, I'm
Nope.
shooting off like bullets.
Yes, exactly. Do not take them all the way off. Loosen these nuts off, and then you're going to strike the center of it with a hammer. That typically will jar them loose. Now I've seen some that are very, very tight inside of there, air hammer around there, chisel to try and get it out of there, possibly even some heat, whatever you got to do to get it out. So the axle, we got to make sure that all of our threads remain in good condition. We need to clean it before we're going to inspect it. This is just like anything. Once we get this off, we're going to be able to see the bearing races. So we'll be able to see our inner and outer races, our outer races for the inner and outer bearings. Now it's a good time to clean them off. Essentially at this point, if I wipe that off and I can see that one of these two bearing races is bad, as far as industry standard is, we would replace both bearings at that point and the whole assembly, not just the cone either. So if I saw one of these two is bad, I would just start pounding them out right away before I would even bother cleaning it anymore. I already know I'm changing them. Then you could start inspecting the studs. The other thing you got to make sure is you need to measure the studs for stretch. You need to make sure the threads are in good condition, that they're not overly corroded, that they're still tight in their bores as well. Same thing with the axle shaft mounting studs. We need to make sure those are in good condition. They're not stretched, not bent. So one of the things you end up doing when you're doing this, if you're not hoeing like this and you do it like I would, and I would get my 25 iron or my 20 iron and I would swing it here with the sledgehammer. Some people, you can end up bending these and impacting them, at which case you'd have to change them. So
I use my air hammer just to chip to pull them out, but it seems to work. Like lots of guys think you're gonna chip it and stuff, but if you're careful, you can get them all out in like 2 minutes.
You just have to be careful. Your air hammer can work as a non-destructive tool. It's just how pushy you are with it, more or less, is what ends up happening. So That's what I thought. So Orion, actually a while ago, you sent it to me. Those tires are $43,000 each. Thanks. I typically tell people they're around $50,000 a piece. So I'm glad I'm pretty close there. And each dump truck has 6 of them. That's a lot of money, right? Just under $300,000 worth of tires on one unit. So if you can become someone who repairs those tires, imagine how much money you could charge for that job. Almost anything you want. If you're the only one who does something, you have monopoly on the market, then you can charge almost anything you want. So we're going to need to clean the spindle. We're going to need to check the spindle threads for damage. You can repair these threads if they do get damaged. I've done it plenty of times. They sell tools for rethreading or redressing the threads. I shouldn't say rethreading it, because if it's that damaged, you're going to end up having to cut it off and put a new one on, or unbolting it and bolting a new one on, depending on the style. Remember, look for our wheel bearing damage. So like I said, I would already be looking at those outer races. If those outer races are good, then I'd start looking at the inner races and the rollers. If at any point, any one of those components in the bearings seem damaged to me, I'd be changing both bearings and all the races. This would end up making your hub garbage. If you have cracked hub like this, it's garbage, no good. There's no way to fix this. If you break a stud or you need to change a stud because it is stretched, you should change the stud on either side of that one, because the one on either side took an impact load when this one broke or loosened off. Okay, so this is industry standard. Change the stud on either side of the one that broke. And a couple different types of studs to worry about, or different applications. So a stud that has a perfectly round head and just these serrations or splines on it, doesn't matter, it's rotational orientation. This one with this clipped head is very, very important to put in the proper orientation. So that clipped head will fit into a bore that is going to look like that. And if you misalign that head, you can end up with this. And now that stud won't seat properly, and you're going to have a situation developing rather quickly. So these are the special tools that they're talking about for seal installation. Typically the ones we get are from Stemco for us, or the on-road people. And they work the same way. Then we'll have seal drivers for our spindles, for the seal, for what the wear ring, and they're going to drive over top like this. It's just a tube that's going to drive perfectly on the seal, and then you can strike on this edge right here with a hammer. And that's how we'll install the other side of a two-piece seal. So these are the different locking methods I was talking about yesterday. So bearing adjusting nut, locking tab, a locking washer with the locking tab, and then a lock nut, jam nut on there. This is the newer version of this. So a single nut with a clip that will engage into this flat, or it'll engage into a groove like this one. This is the brand name of it. It is called a Pro Torque from Stemco. They're fairly nice in the way they adjust, and they will also use that spacer. I was talking about from a Conmet. This is the setup that you would have that has that spacer inside of it. So in between the two bearing inner races, there'll be a spacer that limits the amount of end play and preload you can put on them. You torque this nut to a specified amount, put the keeper in, measure end play, you're within spec, you're good to go. There's no other adjusting for that one. As opposed to what we'll end up doing with the older style, like these ones. This is pretty common for drive axles on a tractor. So the adjusting nut has a dowel pin in it. The lock ring that has that same little tab right there that engages into the slot in the spindle will engage with that dowel. Okay, and then a jam nut just goes over top, torqued to hold this lock ring in tight. And same idea with this couple different dowels. This lock washer will have flat spots on it right here to engage with the flat spot on the spindle.
Oh, there's some that have a little Allen key that goes in there too. I've seen.
Yep. So then you are absolutely right. There is a different style where what they'll do is I believe it's in the lock nut or the adjusting nut. No, it's in the jam nut here. There'll be little tiny Allen screws. So in between the lock washer and here, so there'll be a screw here and a screw here. And you take those out and that's how it locks in place, okay? On some older trailers and different size trailers, even what it is you'll have a setup like this, and then there'll also be a cotter pin coming through a hole in here, okay? Another way to lock it on. They are just whatever it takes to keep this adjusting nut from backing off. That's the goal of all of this. And make sure you have the correct amount of oil. It's not usually that much. A typical trailer axle, probably a liter to just over a liter of oil. So you've got to make sure you're at the correct amount. Drive axle, a little bit different because it shares a reservoir with the drive axle. So you do need to make sure you're filling it properly. And there's actually a procedure for filling your drive axle, which involves tipping it from side to side to make sure that the wheel ends are filled with oil. So drop or two of oil may be recommended on the first few threads. So you're lubricating the threads. A couple drops of oil in between the nut and the flange so that it's lubricated and reduce the friction while you're torquing it so you can get proper clamping. Different ways we mount wheels and rims. These are all, we have, this is probably very typical for what we're going to be using. Rather than stud piloted, we're going to be almost always hub piloted. So same with this steer axle and same thing with this dually on the rear here. This is a good image of the Dayton, how it works. So you can see here our rims. They sort of have, the lines are a little unclear. This red piece here is usually actually part of the green. So maybe should be green there. Same thing with possibly this piece on the front. Maybe not. This is just a bit of a different style. This is the spacer in between the two, that corrugated spacer that I was showing to maintain the space in between the dualies. So you'd put your first rim on all the way, slide it up into this portion here, and it wouldn't be able to seat back any farther. Or actually, that's how that would work. This red portion must be part of the rim. So you would slide this one all the way back onto the lip on the hub here. And now this wheel and rim can't go off anymore. This spacer would slide on then. Now you have to put this rim on. And these are the wedges that will maintain your wheel tightness, allow the clamping force to hold it on in there. Sometimes these pictures don't make sense. Once you look at it in the shop, it definitely will make sense. And we will get a chance to do that too. Usually you're going to be seeing this style rather than this. And like I say, we're going to demount them in the shop, unless you have to change the rubbers on these rims, there's no other advantage to taking them off of the rims. So there's no other reason you would take it off of the spoke wheels. Okay.
In a shop.
In a shop, yeah, unless you're changing the rubber, the tires themselves, there's no reason to take it off. Or you're changing the wheels, right? Maybe your shop has piles of wheels already balanced, ready to go. Well, I find that these two are worn. You can take them off, put them in the worn out pile, ready to be changed, and put new ones on. So if that's the case, absolutely. But to do brakes, to do wheel seals, to do any of the other work you typically will be doing around there, there's no reason to take those off. And it just would add an extra layer of work that would take up more time for no reason. Different types of balancing. So did you do lots of balancing, Ryan?
So with how do I put this? With automotive tires, you would do balancing. With the steer tires in the trucks, a lot of times they do fluid or beads. I have balanced truck tires on machines with weights, but it's kind of silly because if you've looked, everyone here has looked in the inside wheel of a semi truck and seen all the mud in there, and an ounce of weight on the shoulder of the wheel isn't going to do anything.
Mm-hmm. Perfect. So I agree with you completely. Balancing is more of a light duty to medium duty application. When it comes to steer axle tires, probably that's the most time you would balance them. For any reason, you don't want those two. When it comes to heavy duty assemblies, like he said, putting an ounce of weight on the outside isn't going to do a whole lot. But what you end up having is you can get the feeling of having an out of balance tire from mud, dirt, the crap that builds inside of the rim. Okay. And those will cause these problems as well. More often than not, because the way heavy duty is, the tires are so large, the forces are so large on these things, a small little imbalance, like these few ounces here or there, aren't going to cause a huge noticeable imbalance. Now, if you have half your rim full of mud, exactly half of it, I guarantee you're going to have this heavy spot idea here, and you're going to start getting a bounce. I've repaired units that have this problem. And, you know, an operator might say, well, it feels like my tires are out of balance. A lot of times you can just knock all the mud out of the rims of a dually or in between the dually, and then that will take that problem away. So static balance problem is you have a heavy spot on one side in the middle, it bounces up and down. So the greater the imbalance and the faster it's turning, the more it will want to bounce and hop and hop and hop. This is what it'll look like as you're driving forward. The center line of the tire will keep the same. The tire itself will start bouncing up and down on the suspension. This one, the shimmy, this is probably something I haven't seen very often on heavy equipment. Yet again, because it's talking about a small heavy spot in the actual construction of the tread area of the tire with the size and speed that our tires are turning. So because our tires are much larger than passenger vehicles, are they turning faster or slower?
Slower.
Slower, exactly. So that little, and they're much larger, so a small little variation in weight from side to side, it's going to have less impact because they're much larger, so the overall weight is, the overall forces on them are higher, and the speed is slower, right? If you have a little tiny wagon wheel going 100 kilometers an hour down the road, it's spinning like crazy. But if you have a really, really, really big wheel, it's going a lot slower to get that same speed. So
The ratio of mass between your tires, like your rolling components and the main vehicle, is significantly lower on a truck than it is on a pickup or a car.
mm-hmm. Yeah, exactly. So that is exactly why these don't affect them as much, right? Is that what you're saying?
Yes, like the weight of the tire versus the weight of the entire truck, like the tear on your average tandem axle is 19,000 kilograms,
Mhm.
and your tire is not like, so a pickup tire is 44 pounds. The truck tire is about even for a wide base steer is only 260 pounds. But your pickup would have to weigh like 8,000 kilograms to have the same mass ratio to its tires that the semi-truck does to its tires.
Yes, and so there's just more holding it down, so it's affected by these a lot less. So a Honda Civic would be extremely affected by a slight weight off balance tire. You would definitely notice it. Your tractor tire, no, you're not going to notice it. There's a little slight heavy spot during manufacturing. So, but dynamic balance is going to cause a side-to-side shimmy. Okay. Run out. That's nice. This is really, really, really checking really closely on the mounting of your rim-based steer hubs. You're checking for out of round and run out. Okay. Or the mounting to the hub. You're checking here with this. So it's mounting, checking here if it's mounted side to side correctly, or if it is mounted here circularly correctly. I'll be honest with you, I've never done this on a wheel. And I'm sure a manufacturer do make specifications. Again, this will probably be able to tell you if you have bent rims and damaged rims, things like that. At the point where I'm seeing rims that have that kind of damage, where I see bent dents and damage in them, I'm just replacing them. I'm not going to measure the run out on them or anything like that. And how do we balance them? So I think this is some type of manual balancing machine. I know they make machines that you can put heavy duty tires on, to put wheel weights on and all of that. Essentially, you can see all of this side. All it's going to do is it can tip over from side to side. So the heavy side is going to tip down, and you can start putting weights on the rim to try and balance it out. And they're just talking about where you would add weights. You have a spot here, add your balance weights there. That's nice. And dynamic balancing, you have a heavy spot, you're going to try and balance it out by doing this. Yet again, that's nice. Here is where we do need to know why we have some wheel and tire faults happening. So we've talked about scrubbing, we've talked about cupping a little bit. That, if we see that, we can't just call Cal Tire or Ryan and say, hey, put some new rubber on these and send it down the road, because that same damage is going to happen again. It's going to keep on happening to new tires until someone says, hey, why are we changing tires all the time with the same damage on this one? Every time it comes in for a PM, we say this tire is cupped. Okay, why is that happening? So that's what it's going to be our job to determine and repair. All right. What's off alignment here?
Rear axle.
Yeah, the scrub, the thrust angle. We're going to be causing a lot of scrub in this. But if we were talking about a properly aligned vehicle, I would actually align the steer axle a slight amount that way too. So the steer axle all goes the same direction. The frame is going straight down the road this way. And I would, in my mind, say this is good for what? What's that thing on the road?
Crown.
Yes, crown, road crown. Thank you, everyone. So yeah, road crown, that would counteract the road crown. Now, if I have the axles fighting each other like this is what's going to cause that tire scrub. These ones are trying to roll this way, and these ones are trying to roll straight ahead. So something needs to skid in order for this to happen, okay? There is no way that it wouldn't. According to this sentence here, underinflation is more critical as considerable heat can develop in the tire and explosion is possible. I've only ever heard this from here. Have you ever heard anything like that, Ryan? And I'm sorry I keep picking on you. It'll end once we stop talking about wheels and tires, I can assure you.
I have heard of it from overinflation wear. And yeah, underinflation wear can cause some pretty crazy looking spots, especially if you combine that with a little bit of camber wear, or even like too much toe in will wear out the center of the tire like that as well.
Mm-hmm.
But dramatically faster with toe in.
I found it interesting that they said considerable heat can develop in the tire when it's underinflated. In my mind, I imagine that's just because all of these ribs are compressing together and rubbing together when they shouldn't be necessarily. And so it makes a lot more heat in the tire with the flexing and the rubbing of the rubber.
It actually has more to do with the sidewall and those radial cords. And actually the highest amount of heat, where the heat focuses in a tire, is actually the beads. They get really hot there. And that's kind of why you have if you've ever seen a wheel that's worn out without the tire on, those beads can look pitted and horrible sometimes, because there's actually a lot of heat transfer between the bead of the tire and the bead of the wheel. And so when the tire is low, the sidewall will flex and it gets hot in the sidewall. And that's what will cause the tire to fail if you air it back up after it's been driven on flat for a long time, is those cords are actually damaged because they've done too much flexing, and the sidewall will give out, which is a zipper explosion.
Mm-hmm. Yes. Okay. Awesome. Thanks. That's excellent. I'll try and show everybody the example of this in the shop, because it's hard to sort of imagine this in your mind unless you've seen it in real life. But this is how you can tell if you have alignment problems too, if you get this feathered wear. So what'll happen is if I drag my hand or push my hand this way across the tire, it'll feel really smooth, and I'll be able to pull it over that side really easily. Now, if I take my hand and push it this way, it's going to get caught on all of these little sharp wear edges, and it will feel like it's sharp, or not sharp like a knife, but it'll feel rough, like it keeps getting caught on these lips of the tread. And that's a good way to tell that your tire has been scrubbing sideways if you have this feathered wear.
We have some trailers down by the mill, and like they turn side to side all the time. Like they do a lot of sharp turns all the time. So we see that on the tires just from that.
Yeah. So if you have a tri-drive trailer and it's being turned really sharp, tri-drive trailer. Trailers don't drive. If you have a trailer, then when it's turning around really sharp, what you end up getting is it pivots around this center here. So these axles end up moving sideways as it's getting pulled around here. It makes a big circle like this. That's what happens as you're driving around, right? We've probably all seen this. So these ones are moving this way. This is moving this way. This one's going around. This one's going around. This one's going around. So these ones do get scrubbed quite a lot. Usually they're almost sliding sideways, and these ones are just barely rolling, is what I've seen. Is that similar to what you have?
Yeah, because it's they're 53-foot trailers, so they're real long, and they go around tight corners constantly all day, every day.
Oh yeah, so you'll get the front axle will feather in one direction, the rear axle will feather in another direction, and the center axle tires will do a completely different thing. I'd imagine is what it looks like. So different types of damage that happen to on-road or off-road tires. This is some of the damage you get, like when, just like what Ryan has said, when you're driving with flat for too long or low. I'd imagine if it flexes and can get too hot, underinflated, this is the damage you're going to have in the plies on the radial tires and the bias ply tires in the side. It looks like these ones you can only see from the inside, so you wouldn't necessarily see this until it became a bulge or a zipper explosion and ripped out the sidewall and failed completely. This is something we do typically see: fatigue, all these different little cracks in the tire. These tires, depending on the size, excuse me, I think if they were very, very, very large, chances are you'd probably try and repair these with this type of damage too. And look for this: radial sidewall cracks under inflation. So like Ryan said, flexing of that sidewall will cause overflexing, too much stress, damage the cords, damage the sidewall, start ripping and tearing the rubber. If you can see cords through there, no good. More off-road types of damage. It's easier to see it on an off-road vehicle because it's very large, right? We can tell this drove over something really sharp and it cut up the tire right there too. If you see this on an on-highway equipment, same thing. It needs new tire. Punctures and cuts, same thing. If you start seeing this on on-road equipment, no good.
It's easy. Rig mats are a big cause of those.
I would imagine so, yeah. I would imagine so. You can see this one's starting to widen out. That's not going to be good either. Wheel and rim damage. This is the one I'm very concerned about. This one, you have to make sure that your locking rings and components are in good shape, not damaged, not cracked, not eroded, and not sprung. So this is the same one I was talking about, looking like a lock washer. It should not look like a lock washer, okay? And cracks anywhere on the rim as well. They talk about these ones, I think, because they're very dangerous if there is any damage to these. The bud wheels, if there's damage, so much damage like this in the rim, chances are it's probably leaking, okay? The rim itself has, most of the time it's a tubeless tire, it's going to be holding the pressure itself. So any of these cracks, if you develop a large crack inside of a tubeless radial, it's going to leak and be a flat tire. So does that damage happen so often? No, typically it's damage to the flanges, bead flanges here that I've seen, right? Curbing it, that's what's going to damage that. Any questions? Ryan, is there anything you feel I missed that I should have talked about when it came to tires after you've read this book and since you know so much about them?
I didn't read the book.
Yeah, well, don't tell me that. You should have read the book. Is there anything you think I should have talked about when it comes to tires?
No, I don't
I got
think so. Go ahead. Sorry.
Yeah, I have to say, what is the reason that we're putting some nitrogen in tires and other things? Small balls that we're going it, is that for balancing?
Yeah, those are beads.
The small balls, I am not sure what those beads are, what you're talking about. I haven't ever heard of them.
Ryan, can you explain that? Maybe I.
So sometimes they put silicone beads in tires to balance, but if you see funny little rubber balls in there, and it'll be a small number of them, and they're just little. What that actually is rubber material from the inside of the tire that's been mixed with the moisture and rolled around like a little snowball in there.
Oh, okay. So we're drawing it.
And as far as the nitrogen in the tires, that's just because nitrogen expands less than regular air does when it gets hot. It's a little more stable. But yeah.
Oh, it's funny you should say that. I mean, I appreciate that nitrogen and oxygen do have different rates of expansion. How much? So you said nitrogen expands differently than regular air, right?
Well, regular air is mostly nitrogen, so that's why it's a bit of a scam.
Yeah.
Because it's only for very specific high performance applications that it would ever be even remotely necessary. But yeah, it is mostly a scam. But
so I've heard from salespeople a few different reasons why they do that nitrogen thing. I'll tell you, Ali, what I've heard. So I've heard that expansion, keeping the pressures the same, that right? It
More pricier, I guess.
well, yeah, they definitely charge you money to put nitrogen in your tires. It's more expensive, like $5 a tire or something. I have a Dodge, so if anyone has a Chrysler vehicle, they're the ones that are doing this, I believe. I don't know if any other manufacturers are now, but when I bought my Dodge, it was one of the sales features. And so
And I guess you're not supposed to cross contaminate air and nitrogen, something like that, that cause trouble inside.
I've been putting air inside of mine, and it hasn't been a problem for an truck 6 years old. So, so dog just snorted something. Anyhow, the few reasons I've heard about nitrogen in the tires, like he said, rate of expansion, but again, 79% of the regular air we breathe is nitrogen anyway. So is that extra 21% of oxygen, mostly oxygen and other carbon dioxide and different types of other gases going to affect it that much? Like he said, probably not. I agree with that too. The other things I've heard is that you get less leak down because they say nitrogen's a bigger molecule than oxygen, and the oxygen will leak out of your tire. The air, they tell you the air leaks out of your tire eventually because it's so small, and the nitrogen will stay in there. That's one I've heard too. That's not necessarily true either. I think there, like he said, there's some very specific applications, and I think this came from the high performance land where they might be using pure nitrogen to fill tires with. That's where you might notice it. I don't think would make much of a difference in your vehicle. And to be honest, if you cross contaminate, so you go from 100% nitrogen, you've leaked down from 100 psi to 80 psi, and you replace that extra 20 psi volume with air, 80% of that air is nitrogen anyway. So the actual contamination there is fairly small. And I mean, now what does that contamination do? Well, Ryan just said the little pieces of rubber mixed with moisture, which you will have in regular air, unless you have a really good air drying system for your air supply system, it builds up inside of there and it essentially takes off little pieces of the rubber, right? That's where those little balls come from that Ali was talking about, or the certain type, not the ones purposefully installed for a reason. But yeah, so there is a little bit of wear that happens from contamination, from moisture in the air and the other different gases in there. So it makes a little bit of sense. But would I pay the extra money for it? I mean, like I said, when I need air in my tires, I just air up my compressor and fill them back up to the pressure. So
Another notable thing is that if you happen to have steel wheels with no coating on them or the coating's rubbed off, they will not rust if you don't have oxygen in the tire.
They won't rust if you don't have oxygen in the tire. Oh, okay. The inside of the rim, you mean, right?
Yep.
Yeah. Okay. That absolutely makes sense. So would be a good advantage. Nitrogen is what we call an inert gas. So does not like to react with things, whereas oxygen really likes to react with lots of things. Oxygen makes fire, oxygen makes rust, oxygen is a fuel for a lot of different processes. And yeah, for corrosion, in the absence of oxygen, iron cannot oxidize. So absolutely, that's a good point. Nice, thanks for that. I've never even thought about that one before.
And one more question regarding to the tire. Do we have to go with the PSI written on the tire, or we have to take a look at the car or the sticker on the door, whatever it says? That's the trouble. I'm trying to find out what exactly I have to go.
That's a good question. So a lot of times for things like, for us in the heavy duty world, so I would say go with what the tire says. And if you're selecting the correct tires for the unit, they should be very, very close within that same range, okay? Now, the thing is, if you select a tire that's weight rated for the same, you need to change tire sizes for reason, right? Now that sticker might not necessarily be accurate for the same tire size. Are most vehicles fairly consistent and along the similar vein? Yes, there is going to be a variation though. What would you say on that, Ryan? What would Cal Tire tell you to do in that instance?
So if you're for automotive, and there's a point that I'm going to bring up for heavy duty as well, but for automotive, if your tire pressure on the side of your sidewall for your maximum weight, because we have to remember that maximum pressure is for maximum weight, and the more weight, the more pressure. If your vehicle says 32 psi and say your tire says that it's good for 80 psi, you've got too heavy of a tire on that vehicle, and you're not going to have the performance out of that tire as it would be if it was on like a heavier vehicle where it would need 80 psi. As far as for heavy duty, most of our tires that are in load range H or I, which is 14 or 16 ply tires that are common on our trucks on the road, the actual max pressure is 120 psi. Mind you, the only time that we're ever going to have a heavy enough weight that our tires would be close to that maxing out, we're going to be above what our allowable axle weights on the highway are. So we don't need to put 120 in the tires on our tri-drive winch tractor. We actually 100 or 105 or even 110 is fine. The industry standard seems to be 100 psi. But those maximum pressure on those tires are rated for 120, but that's at full load. And if you run that tire at 120 at 50% capacity, like unloaded weight, you will burn the centers right out of the tires, and you'll have cupping and heel toe wear that was totally unnecessary.
Yeah, that's what I've seen too, Ali, is in heavy equipment, the maximum, it says it's a maximum 120 psi. Now, industry standard seems to be anywhere from 85 to 105, and that's largely determined by the individual operators or fleet managers, service managers, things like that, depending on where you work. And they're determining this based on the application and the amount of weights that they're hauling. So does that answer your question?
Like for tractor trailer, I usually go like 90 or 100 for all, and a little bit less for the front. And if it's a tire boss, then the jobber can inflate and deflate it. So that's another problem. In most cases, if it's a tire boss, when it just sit down, the guy cannot tell me that where the leak is, and then it just go flat, and then there you go. You got to lift up all one by one and just fix and use the grease and do eater, whatever, just meant it.
Yeah, so there's a bit of a variation, but yeah, so I agree with Ryan that stamp on the side is for a maximum amount, and you should base things on application, what you expect to be seeing out there. All right, so right now I'm going to stop recording first of all,